Assalamualaikum and very good morning to all of you. Welcome back to the class. This is the part 2 of topic 3, which is the seismic action on buildings. Okay, this is to recall what I have mentioned in part 1, which is on how the earthquake acting on the building, or how the forces of the earthquake actually acting on the building, which actually it acting horizontally, which is from the inertial forces when it try to resist the acceleration of the ground. Okay, this is the simplifications of the forces, and this is the factors affecting severity of forces, and this is the how to determine the fundamental period of vibrations, which is strongly depends on the structural systems, materials, and the total height of the building. Okay, in this topic, I will tell you, or we will discuss on how to determine the magnitude of forces acting from the earthquake, or we now namely as the base shear force. Okay, base shear force is the total forces acting from the ground. Okay, before we distribute, so it will act on the story joint. So this is the step. As you can remember, in our last lesson, we learned on how to develop the design response spectrum for particular regions, seismic regions, and depend on the soil type, depend on the importance factor, and depends on the reference peak ground accelerations, as well as the behavior factor. So this is the fundamental period of vibrations of the building we learned before. From the design response spectrum, we can obtain the magnitude of spectral accelerations. Why we need to obtain that value? Because we have to insert that value as input in this equation. Okay, you can find the equation 4.5 in page 57 in Eurocode 8. This is the equation. Base shear force is equal to spectral acceleration at fundamental period of vibrations multiplied by the total mass of the structure, and then multiplied by the correction factor. This is the base shear force, the total forces acting. And then we distribute the total forces by using this equation. You can refer this equation in Eurocode 8, page 58. So if you have 3-story building, so you will have force at story number 1, force at story number 2, and force at story number 3, which will become the total force or base shear force. And the total masses is the mass from story number 1, total mass from story number 2, this is total mass from story number 2, and total mass from story number 3. We sum up together to get the total mass of the structure, and then we insert to this equation. Okay, that's the step on how to determine the base shear force, and then how to distribute the forces on every story. And the question? Okay, no question. Good. Okay, this is from page number 57 in Eurocode 8. This is the equation I mentioned before, and this is the description of every parameter. And this is the correction factor. The lambda is the correction factor. The value is equal to 0.85 if the T1 of the building is less than or equal to 2 times the TC, and the building has more than 2 stories. Otherwise, it equal to 1.0. So for building which has more than 2 stories, okay, and this one, okay, so the correction factor is equal to 0.85 automatically. Okay, for 1 story building, the value is 1.0. Okay, so this is the from page number 58 in Eurocode 8, which is the equation on how to distribute the base shear force to become lateral story force for every story. We use this equation where it's equal to total base shear force times by the Zi times Mi over the summation of Zj times Mj. So we can look here the what is the Zi. Okay, let's say we have 3-story building. So this is the Z number 1. Let's say I is number of story. This is Z1. This is Z2 and this is Z3. So Zi is the total height of the first story from the rigid basement. So what is the value of Zi? What is the value of Zi? Yes, it's equal to 3.3 meter. Okay, from rigid basement here up to this level is 3.3 meter. Z2 is from the rigid basement up to here. So what is the Z2 now? 6.6, good. And Z3 is from the rigid basement to the top. It's cumulative, okay? It's cumulative. What's the value?
9.9.
Okay, good. It's 9.9 meter. Okay, students always do mistake in this one. Okay, they make it Z2, Z2 also 3.3, Z3 also 3.3. It's not like that. Okay, it is a cumulative height from the rigid basement here. Okay, so make sure you can do it rightly. Okay, let's go to the example number 1, which is based on the data given, determine the base shear force and the lateral load acting on every story. Okay, this is the given data, which is the mass for the story number 3. Okay, mass comes from the safe weight of the structural elements, comes from the other dead load and other some portion of imposed load, because during the earthquake not 100% imposed load acting on the building. Let's say you have people here, maybe not 100% building is occupied, so we reduce the percentage of imposed load acting during the earthquake. Okay, so this is from message number 3 up to this level. For number 2, for this portion, and this is for number 1. Okay, M1, M2, M3, and this is the fundamental period of vibrations. Okay, let's say it's given here is sometimes the fundamental period of vibration is given, and sometimes you have to determine from this given height. Okay, if the value is not given, so you have to determine based on these equations first. You have to determine first. If the value is given, so you just use this value. Okay, and then the soil type D, design response spectrum type 1, reference peak ground accelerations equal to 0.12 G, Beware factor 3.9, importance factor 1.4. So what we have to do is this one, you have to refer to the, let's say we use ground motion, a soil type, we refer to the Eurocode 8. Okay, this one is a Eurocode 8. Let's say type 1. So we refer to the soil type D here. Soil type D, the S factor is 1.35. This is the TB, the TC, and then the TD. So if the period of vibration is 0.5, which equation we have to use? Recall back our last lesson.
3.14 equation.
Okay, so we use equation 3.14 here because our T1 here is 0.5, which is greater than the TB, but less than the
0.8.
TC. Okay, so it's between TB and TC. We use this equation. So this one, okay. Okay, can you use your calculator for me? This is alpha G is equal to alpha GR times the importance factor. What is the value here?
0.168.
Okay, just like our previous lesson, 0.168. So our fundamental spectral accelerations. Okay, is it?
0.145.
Okay, 0.145. How about our total mass?
2,221.194.
Okay, 221.94 kilonewton. Okay, and what is the value of correction factor shall be?
0.85.
Okay, because the building has more than 2 story and then the T1 is less than the 2 TC. So it's 0.85. So what's the value of the base shear force?
273.85.
Okay, this one. 273.9. Okay, make it one decimal places is enough. Okay. Everybody got this value? The unit is in kilonewton. So we got the base shear force, I mean the total forces acting on the building. And now we will check what is the value of forces acting on every story. So I prefer you also create this table to make your calculation easier. Okay, so this is your total height. Okay, Z, I mean, Z1 is equal to 3.3, Z2 is equal to 6.6, Z3 is equal to 9.9, as we mentioned before. So you just multiply what is the Z3 times Z3 times M3. What is the value here? Z2 times M2 and Z1 times M1. And then you total. You sum up all the product of Zi times Mi. Okay, I give you 2 minutes to calculate. Okay. Take your time. Okay, anybody got the answer here?
5718.3.
Okay, 5718 one one
Mm.
eight one eight or 13.
Salah tu. 7.5.
Okay, next, what is the value here?
1313.
13. Okay, good. What is the value here? Story number 2.
5043.06.
5043.06. Any objections?
No.
Okay, good. Okay, how about story number 1?
2904.79.
2904.79. Okay, how about the total? The total value here?
13661.14.
Okay, 13. Okay, good. Okay, semua dapat sama tak jawapan dia?
Dapat.
Okay, good. So, once you got that, so you can distribute all the forces by using the equation, this one, this equation tadi, Fi is equal to Fb times Zi Mi to the Zjmg. Okay, this is the equation. So, what is the equation? The value of F3 here?
One 114.54.
Okay, 114.5. Okay, good. How about story number 2?
101.1.
Okay, good. 101.1. How about the last one? The bottom story?
58.2. 58.2.
Okay, good. 58.2. And then you sum up the total, it must be equal to the FB, which is 273.9. Okay, as checking. Okay, and then you can draw this figure, elevation view, and then you can, okay, you can see clearly this is the F3, F2, and F1, and the total shear force is here, acting from the ground actually. Okay, any question up to this level?
Okay.
Okay, so if okay, let us do this one. Repeat the same situation with different value of behavior factor. Okay, last time we used the behavior factor is equal to 3.9, which results in different this value of spectral acceleration of fundamental period. So what will happen if we use lower and higher value of behavior factor? Okay, well, we will discuss this one later. I wish, okay, I want you to try by your own. Okay, I can divide. Okay, this 2.3 will be conducted by Farahin and one Zunaira. Okay, can you do it? This one is Shaira and Arina. Okay. 4.7 will be conducted by Alicia and Aina. Okay, this one Hanan and Atira. Okay. So I give you around 5 minutes, and then we will discuss the value. Okay, and this is example 2. Okay, we will discuss later. So thank you very much for your attention. See you after 5 minutes. Thank you so much.